Welcome back, everybody. It is Mr. Sullivan once again, and we are here to talk about transformations of functions, part one. This is Optimus Brust here, the famous transformation. So let's take a look here. We're going to take a look over at this side. We have a graph. We have this function right here. Really random. Just some points. -3, 0, boom. 0, 3, boom, and 3, 0, boom. So this is our x, this is our f of x. Remember, f of x is just fancy for y. Okay, it's just fancy for y. We need to remember that. But we want to know today, what would happen if I took that and added 2 to the function? All right, so whatever my function is, I just want to add 2. What happens to that function? Well, let's see what happens to this function. So if I add 2 to this function, now the value at -3 was 0, but now I'm going to add 2 to it. So now that value is 2. So I'm going to go over -3 and up 2. At 0, the value of the function was 3, but I'm going to add 2 to it. So now the value of the function is 5. So 0, 5, I plot my point. And at x was 3, my value was 0 plus 2 again. Boom, 2. So now we can draw this function. So it looks like by adding 2 to this outside of the function, to the end of the function, when I added 2 here, what happened? It translated, it moved up 2 units on the graph. All right, it corresponded exactly like we probably would have thought and moved up 2 units. Okay, now let's take a look and see what's going to happen if we have another transformation. All right, let's go over here. Now we are going to subtract 4. All right, so we're subtracting 4. Let's see what happens to our function this time when we subtract 4. Here we go. So, at -3, my value of y was 0, but I'm going to subtract 4 from that. So that's 0 minus 4, so it'll be -4. So I go to -3, my point, -3, -4, 1, 2, 3, 4, and we have it. Over here, now I'm going to subtract 4 again. 0, 3 minus 4 is going to be -1. So -1 is right here, 0, -1. Last but not least, at x is 3, my y value was 0. Now I'm going to subtract 4 again. So now my new y value is over 3, down 4. We can look at my graph right here. Bada bing, bada boom. And there we go. Exactly what we probably would have thought. I mean, if I had asked you what you think will happen, if I take a function and I subtract 4 from that function, you would think it would move down. All right, so what do you think would happen if I was going to add k units to a function? What do you think would happen if I added k units to this function? All right, well, if I add k units, when I added units on this one, it did what? It did just like we thought. It went up. What would happen if I subtracted k units? It would go down k units, right? So you want to think about this for a second. Anytime we are adding or subtracting a value to our function, it translates the graph in the same direction. Adding, I'm going to go up. Subtracting, I'm going to go down. Okay, so I want you to look at these. We have these on your paper. These are 3 really important families of functions, all right? They're very, very big. These are the big ones. You've done quadratic functions before. This is called the parent function, all right? They're parent functions. In other words, this is like the basic function, right? So this is the basic overall function. This is as plain Jane as it gets, all right? We did linear equations in Algebra 1, y equals x. That's its parent function, okay? This is this parent function. The coefficient's 1. Notice the exponent for any quadratic is the power of 2. What shape is it? Well, this shape is a U shape. So anytime you have a U shape, it's going to be a quadratic, all right? Well, that's what the quadratic is going to form. There's a couple of points here I want to really understand because we're going to start moving things around, and I want you to see a couple of the points that definitely matter. So -1. When I'm at -1, I'm at +1. And that should make sense because when I plug a negative in, a negative times a negative is a positive. When I'm at 0, I am at 0. And again, the reason I want you to care about these ones are, these are the points that we're going to shift around later today, all right? When I'm at +1, I'm also at +1, all right? That makes sense. So that's a quadratic. Anytime you see an x squared, you know it's going to be a U-shape. When you see these U-shapes, you should be thinking quadratic function. All right, let's talk about a cubic function. These are a little bit different, and here's why. When I plug a -1 in, a -1 to the third, negative times a negative is a positive, times a negative is a negative. So when I go over 1, or left 1, I go down 1. I still have my 0, 0 point, and I have my 1, 1 point. But these go down, or they come up, and they go a little bit almost flat, and then it comes up on the other side, okay? Absolute value functions, these are not U-shaped, these are V-shaped, all right? Some of you draw your U's like V's. When you are drawing a graph with an x squared, you need to make sure it's U'd, it's round at the bottom. When you are drawing an absolute value function, you need to make sure that you are drawing it straight, like a V. Okay, so the great thing about absolute value, anything inside an absolute value becomes positive. So the absolute value of -1 is +1. 1 over 1, up 1. The absolute value of 0 is 0. The absolute value of 1 is 1. Okay? And you'll notice this is kind of like a line, right? The slope of this line is a +1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. The slope of this line is -1, right? It's kind of like we're making two distinct functions. But the reason why this happens is, imagine -x, the absolute value of that was going to be what? X, right? So you have to be very careful there. All right, we now have that. So let's see what happens if we add a value to the inside of these functions. So we know that if we have a function such as this and we add a k, on the end it goes up, k units. If we subtract k units, it goes down, right? All right, so now I'm talking about the inside. So like x plus 4 squared. What happens there? Or x minus 3 to the third. What happens there? Let's take a second and see what happens when we do those shifts. All right, let's go to Desmos. So this is Desmos. I have our function here. This is our base function. So you have to remember now, the one in green is going to be our base function. So now I'm going to put in here x minus 4 and square it. X minus 4. So if I plugged in x minus 4, you would think minus left. But let's go over here. Remember, our green is our parent function. What happened when I put in -4 here? It actually went to the right, didn't it? All right? Now I'm going to change this a little bit so we can do some all at the same time. Now you can see, all right, when I'm subtracting something here, any number I'm subtracting is going to the right. That's crazy. All right? Now I want you to think about this. I'm going to subtract a negative number. All right? Subtracting a negative number is like adding a number, correct? So this would be like hx plus 4. Let's try it. Let's see what happens. X plus 4. It shifted it to the right 2 units. Okay, so we should probably check this out with our other parent functions. Let's see here. Here's our parent function of a cubic. It comes up and turns nicely. Let's try it. Y equals x minus 5 to the third. X minus 5 to the third moved us 5 units to the right. It's the opposite. So when I put it on the inside, it's doing the opposite of what I would expect. Let's change that to plus. Plus moved it to the left. All right? So right now, it appears as though anytime I put something inside here, it's doing the opposite of what I would expect. Let's try another one. Y equals, let's find some absolute value bars. X, we need our parent function. There's our parent function. All right, so our parent function right now is in purple. Okay, and x minus 6 on the top one. So minus 6, you would think it moves left, but instead what happened, it moved it to the right. Okay, let's say I add 6. It moves it to the left. So no matter what I'm doing here, it's doing the opposite down here, right? It's definitely doing the opposite. Here's our slider. I'm adding 4. It's going to the left. The more and more I add, it goes to the left. Now I'm adding a negative number, and it's going to the right. It does the opposite on the inside of what I would generally expect to happen. That's pretty crazy, right? So let's talk about some generalized translations. So the first one, f of x, I take any function and I add a value k to it. It is a vertical translation. So anything on the outside is a vertical translation, and they are exactly the same as the shift. You may want to write that down. So this is a translation that is on the outside, right? So let's type that down in here. These are outside shifts. Boom, nice and big. Because I'm adding on the outside. And when I add on the outside, it does exactly what I think. All right? It shifts it up k units. If I were to subtract it, it would shift it down. So anything on the outside is exactly like I think it is, and it's a vertical translation. What about on the inside? So anything on the inside shift. Now notice I wrote this a little bit weird. The reason I wrote this weird is because, first of all, it's the opposite, right? I'm not adding. It did the opposite. So anything on the inside, right? Anything on the inside is a horizontal translation, and they are opposite of the shift. So we would say f of x minus h units. Okay? So anything on the inside is opposite. Anything on the outside is exactly like it is. Outside vertical, inside horizontal. Those are big, 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 big points. All right? All right, here we go. So let's try some. All right, we're going to write g of x, and g of x is just another way of writing f of x. It's the same thing. It's going to be a y equals something, right? But g of x lets us know now that we have a new function. All right, so we're going to write g of x in terms of f of x after we do a certain transformation. And that transformation here is we're going to translate the graph right 3 units and up 2. I like to look at big things. So here's a point, here's a point, here's a point. So I'm going to shift them right 3, 1, 2, 3, and up 2. Boom. This point here, 1, 2, 3, and up 2. And then this point, 1, 2, 3, and up 2. And I'm going to do my absolute best here to make this look like a semicircle, and that's terrible. But you can do a better job than I can probably, all right? All right, so now let's talk about what is g of x. All right, we're going to write g of x in terms of f of x. So let's write f of x here. Now, any shift on the inside is a horizontal shift. How many units did we shift horizontally? We shifted right 3. Now you need to remember, anything on the inside is doing the opposite of what we think. So instead of plus 3, I'm going to put a minus 3 because it's the opposite for horizontal shifts. Anything on the outside is exactly like I see it. I'm going up 2, so I'm going to do plus 2. So my new function, g of x, is f of x minus 3, a right shift, plus 2, a vertical upshift. I want you to pause for a minute and try this one on your own. Draw it yourself, and then try and write the g of x equation. All right, let's take a look here. So I'm going to shift it 4 units to the left and 5 down. 1, 2, 3, 4, and then down 5. 1, 2, 3, 4, 5. Right there. This point, 1, 2, 3, 4, and then 5 down. 1, 2, 3, 4, 5. Last but not least, 1, 2, 3, 4. 1, 2, 3, 4, 5 down. Now, if your graph looks different, and not because it's just not straight, you probably counted wrong, okay? All right, let's take a look. So I have f of x, and on the inside is my horizontal shift. So what is my horizontal shift this time? I went left 4. Left is going to be the opposite of what I think. So I think subtraction. So the opposite of that would be plus 4, all right? And then I'm going down. That's a vertical shift. Vertical shifts are on the bottom, so I'm going to do a minus 2, just like so. All right? Okay, let's take a look at this function. So we're going to do 2. I'm going to do the first one, and I'm going to try and let you do the second one. We need to write a function that is a translation of the parent function. All right. So you remember now, this is a U shape, so it's a quadratic. So I'm going to just start with that. So a quadratic, we'll call f of x, is equal to x squared. So we have something squared here. All right, let's see. Now if you recall, our points were 0, 0, negative 1, 1, and 1, 1. So let's see, how many did I shift for this point? I went to the right, 1, 2, 3, 4. 4 to the right. How many did I go up? 1, 2, 3. I went 3 up. So a horizontal shift is on the inside, and it is the opposite. So the opposite of plus 4 is minus 4. The vertical shift is on the outside, and it is exactly like we think. So it is plus 3. So the first thing I did was I identified the parent function, then I identified the shift, okay? I want you to pause the video and try this one on your own. Great. So let's take a look here. I have g of x. It's a v. The parent function is the absolute value of x because it's a v. Here we go. So I know I'm going to have x and a horizontal shift and then a vertical shift. So let's see my horizontal shift. It looks like it only goes one spot, right? Because it was a v at 0, 0, 1, 1, and negative 1. So it goes left 1. So the opposite of left 1 is plus 1. How many am I going down? 1, 2, 3, 4. And that's an outside subtraction of 4 because outside is exactly like I expect it to be. All right? There you have it. Do the best you can on this. All right? There's not a lot of practice questions, and the reason is it takes a lot of space, and I honestly think that once you try one for real, legit, it works. If you need to, though, take another crack at that corrective assignment. All right? I hope you're in the moment. I hope you're learning a ton. If not, make sure you ask for help as soon as you can. Sully out.